All right, so today's the first day of trig, and let's look at this question here. What we're going to be working with a lot are right triangles to start out with trig. And it says if one other formula that we used for right triangles is called the Pythagorean theorem. And so what we knew about the Pythagorean theorem is that if you knew two sides of a right triangle, you could find the third by applying the formula a squared plus b squared equals c squared, or c squared minus a squared equals b squared, right? Where c is always the hypotenuse. Okay. So now, if a side A has a length of 12 and side C has a length of 24, and you want to find side B, well, you're going to apply the formula 24 squared minus 12 squared, and that will give you b squared. And in the second question, it's saying, what's the longest side of the triangle? Well, the longest side is what we call the hypotenuse, and it's always going to be C. It's what we call the hypotenuse. Now, if you wanted to see if you plug this in the calculator correctly, 24 squared plus 12 squared is actually 432, but the last step is to take the square root. So the square root of 432, b is approximately 20.8. And yes, you will get decimals, and sometimes you will get to leave it in radical form. All right, so what are we talking about with SOHCAHTOA, or trigonometry? And that's what we're going to talk about next. So in this box, I want you to draw a right triangle with legs. So remember, the legs of the triangle are what we call A and B, and the hypotenuse is what we call C. So you want to draw a right triangle with legs of 3 inches and 4 inches, and a hypotenuse of 5 inches. So just simply draw a right triangle that's got a side of 3 and a side of 4, and automatically that side right there will be 5 inches long. Okay, now we're going to draw a triangle 1, but we're going to dilate it by a scale factor of 2. So what you're going to do is just take all the side lengths, or the coordinates, whichever, and multiply by 2. So now you're going to have a side of 6 and a side of 8. Now just because of the way the grid is, I'm going to have to turn this drawing around because I think I only have enough 1, 2, 3, 4, 5, 6, 7, 8, yeah. So I could fit it all on one page. Draw this here. This is 1, 2, 3, 4, 5, 6. So this is what a 6, 8, 10 looks like. And lastly, we're going to dilate it by a scale factor of 3. So this would be a 9 by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to look like this. So what we can say is that all these triangles are similar to each other, right? Because they all have a scale factor, so they're similar triangles. So we're going to expect the angle measures to be the same. And I will go ahead and tell you that the smallest angle is across from the smallest side. So this is the smallest side here. This angle here is actually a 35. This angle here is a 55. And here's my 90-degree angle here. All right? And once again, if I look, this is the shortest side, so this angle here is a 35. This angle here is a 55. And this angle here is a 90. Notice all the angles are going to be the same because they're similar triangles. Here's my 90 degree. Here's my shortest side, so this angle here is a 35. And this one here is a 55. Okay? Now let's use that information and move forward. It says measure all the sides and angles. So I measured the angles for you, and we labeled all the sides. Now we're going to label the smallest side A, the middle length B, and C is the hypotenuse. So in the first triangle, this would be A, B, and C. We're just using this to stay consistent. So it's a 3, 4, 5. So if I did the ratio A over C, it'd be 3 over 5. And if I did the ratio of B over C, that would be 4 over 5. And if I did the ratio of A over B, that would be 3 over 4. Let's look at the second triangle. The measure of side A was twice the measure of side A in the first, so 6, 8, 10. And then my ratio would be 6 over 10, which is the same as 3 over 5, 8 over 10, and 6 over 8. And lastly, triangle 3 was 3 times the size of triangle 1. So it was a 9, 12, 15. And side A over side C was 9 over 15. Side B was 12 over 15. And the last one was 9 over 12. Okay, so these are our ratios that we're setting up. They're going to have meaning in a minute. All right, so now let's go ahead and compare these ratios to each other. So side A over side C in the first triangle was 3 over 5. In the second, it was 6 over 10. And in the third, it was 9 over 15. And what you should notice is that they're all similar to each other. If you divide this by 2, you get 3 over 5. If you divide this one by 3, you get 3 over 5. And you'll notice the same thing for the second ratio. This one's 4 over 5, 8 over 10, and 12 over 15. Again, they're all equivalent ratios. They all equal each other. And that's how we know they're similar triangles. And the third one, we've got 3 over 4, which is equal to 6 over 8, which is equal to 9 over 12. Now, what makes these interesting is if you look at these notes down here. It's kind of blurry. The length of a leg opposite angle A over the length of the hypotenuse is sine. So if we're looking at this angle, that's our focus angle. Opposite over hypotenuse is what we call the sine. Cosine would be adjacent, so next to, which would be right here, over the hypotenuse. And the tangent is opposite over adjacent. So I'm going to call this the opposite side. This, in this case, is adjacent. And this angle here, this side here is called the hypotenuse. So if we look back at these ratios that we just discovered, it doesn't matter what triangle we're looking at because they're all similar. This ratio here of side A, remember this is the angle we're focused on. Side A was the opposite. This is adjacent. It's next to it, and this is the hypotenuse. So this one right here is actually your sine ratio. In the second example here, we're looking at side B, which is adjacent over the hypotenuse. This is your cosine ratio. And the third situation is what we call tangent. And this is where SOHCAHTOA comes from, and this is all about trig. Basically, you can find missing side lengths and missing angles in a right triangle by using trigonometry. So the Pythagorean theorem isn't the only way to find missing measures. All right, so let's go ahead and write this again. Remember, if you're doing side A, so I'm going to just redraw this again because this is going to be the important part. This is opposite. This is what we call adjacent because it's next to. They share a side. And then this is always the hypotenuse because it's across from the right angle. Okay? So side A over side C, well, that's opposite over hypotenuse. We call that your sine. Side B over side C, which is adjacent over hypotenuse, we call that cosine. And then lastly, if you take the opposite over the adjacent, we call that the tangent. And remember, this is opposite over height. This is adjacent over height, hypotenuse. And this is opposite over adjacent. So if the angle changes, you can still set up the same ratios. They'll just be, sine is always opposite over hypotenuse. Just so you know. All right, so let's, you're going to do another tide writing assignment. You're going to write an email to Kayla. She's out today, and you're going to explain how we discovered setting up the ratios of sine, cosine, and tangent using what we just did above. And then you're going to write each ratio below. So for example, if I'm looking at the sine of A, that indicates that the angle I'm looking from is angle A. And sine, remember sine is opposite over hypotenuse. So the opposite angle is 8, so it would be 8 over 10. And you can simplify it if you want, or you can just leave it 8 over 10. You could also write it as 4 over 5. Now let's look at number 4. This time the angle in question is changing. It's going to be B that is what I'm looking from. So if I start from angle B, and the sine of B, now my opposite angle is 6. My hypotenuse stays 10. So please note, this indicates what angle you're looking from. Okay? So you are to finish this assignment. Then you have 10 problems called Trig Ratio Lesson 34, numbers 1 through 10. You need me to check that. I will check it and give you a grade on it. And then you may move on to IXL R1, where you can practice this skill even further. All right, good luck, you guys. I'm going to end with this really awesome video. I got to find it. Hold on. And you have the lyrics in front of you. It's the bomb.
If you write. Good morning, guys. I am so excited because we are finally going to start our unit on trigonometry this morning. Miles.
Is there any way we can make this more fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know, you know, I go psycho when I see a triangle. You just can't sit, you gotta get tricky with it. All that's it, 3 angles, 3 sides. You T-R-I-G, all up in my eye. Soka, Toa, will tell you where to go. You just gotta know about H, A, and O. Everybody looking at a glance at the box. The H while P is sitting across. Theta, theta, is that the eta, eta? So on it, for the look, I don't mark it. Beside you ain't touching, it's the O-P-P. Making it tricky, we want you to see. Yo, what's that last side you say? It's gotta be the 80J. Get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it. What? You wanna solve with a trig? Watch your step, you might fall. Try to work this game. Soak it up, soak it up, soak it, soak it, toe up. In the middle of the problem, don't know which one, huh? You gotta know which angles and sides that are missing and given in the problem. They're the guys. You can come with me, all these problems I've tried. Heard it's hard, well then somebody lied. It's soak it, toe up, helps you to study. So you know when to use each one. Then you got the O and HYD, so let's you know such a way to go. Let's say now you got the HYD and the ADJ, then cosine's the way, yes, y'all. But there's one more. You got the legs? That makes it, hey, it's getting tricky with it. Get tricky with it. Get tricky with it. Get tricky with it. Roll with me right now. If you need a side, you gotta know 2 things. Okay, let's ride. You need an angle and one of the sides. Get you is where does X reside? See it up high, that's how you know to multiply. So easy, you get it on your own first try. Trig to the maximum, I'll be axing them. How about the one time you gotta use division? Only if X is down below. X and the angle will switch, you know. Last case, X angle find the time. So let's get it, trust, the data is the goal, get it alone. Calculators, you know, when I say go, take the inverse of the numbers on the right, hit equals and show it off. Now you got it, get tricky with it. Get tricky with it.